Hello. In previous lecture, quality of water, we discussed about the what is the basic idea about the quality of water. Okay. Then how we maintain the quality of water. Okay. What are the different use of water? Okay. And how that water is gets polluted and how it affects the environment. Okay. So this basic part we discussed in the previous lecture. Okay, so these polluted water, which leads various waterborne diseases like cholera, leprosy, malaria, fever, typhoid, gastro. Okay, so these are the various waterborne diseases. This is why due to contaminated water or the water which contain bacteria, and due to consumption of this water, these different types of diseases entered into the human body. Okay, so in previous lecture we discussed about the quality of water. Also we discussed about the introduction of quality of water. That is, quality of water depends upon dissolved and suspended matter, may be biotic, non-biotic, and water non-potable, unsafe for the consumption purpose when the discharge of the effluent and sewage into the water bodies. Okay, and that leads various waterborne diseases. Next, we discuss about the sampling. Sampling, it is nothing but simply the collection of water sample for the analysis purpose. So you can collect the water sample below the surface level up to 40 to 50 centimeter, so that you can avoid the impurities which enter into that your water bottle or during the sampling process. Okay, so that you have to take some precautions. That is, you have you have to collect the water sample below the surface level up to 40 to 50 centimeter. Okay, second thing, you should collect the sample in a glass bottle. Okay, so these two things should be always keep in remember during the sampling. Basically there are two methods we are using for the sampling. It is grab sampling and composite sampling. Grab, it is nothing but just collection of sample from a single point and at a single source. That is called as grab sampling. Composite sampling, it is nothing but the collection of sample for over a period of time, after 2 hours, 4 hours, 6 hours, 8 hours, and that sample we have to mix together so you get a homogeneous mix, and that indicate the average characteristics of that water. So that is the composite sampling, and mostly we prefer this composite sampling for the laboratory purpose for a better result, for accurate result, and for the design of water treatment plant. Okay, after that we discuss about the analysis. So analysis, it is nothing but the examination of water sample. Okay, so we are going to test that water sample in laboratory, and that is what nothing but the analysis. Okay, so what are the advantages of analysis of water? So the first one is design of water treatment plant. That is the one thing. Next, to check the routine operation of water treatment plant. Next, help to suggest the method for water treatment. Next, judge the quality of drinking water. Okay, so you can design the treatment plant according to analysis result. You can check the routine operation of water treatment plant by using analysis. Help to suggest the different, if you want to modify the treatments, you can modify on the basis of analysis result. And you judge the quality of drinking water that you are going to supply for the community consumption purpose. Okay, so that also you can monitor it by after the analysis of that water. Next, impurities in water. Okay, so in previous lecture we discussed about various impurities, that is physical impurities, chemical and biological impurities. Okay, so what are the physical impurities? So color. So basically the water, pure water, or you can say the natural water, it is a colorless water, but due to the mixing of, or due to the presence of solid in the form of suspended solid or in the form of dissolved solid, that water gets color. Okay, and that colorful water we not accept for the drinking purpose and for the domestic purpose. You all of you know about rainy season. In case of rainy season, what happened? Whatever that soil get mixed with the water, and that change the color of red, and that red color water we can't accept for the drinking purpose. Okay, so that is what the color. So pure water, or either you can say the natural water, it is a colorless. And if some solid get mixed with that water, that change the color of the water. Okay, sometimes some sewage get mixed with the water, that also change the color of water. If you are going to discharge solid waste, that also change the color of water. Again, if you are going to discharge the industrial effluent, that also change the color of water. So that is the first physical characteristic, the color. Next one is the taste and odor. Yes, the water, yeah, whatever that water you are going to use for the drinking purpose, that is the tasteless and odorless. That means pure water, you can say it is tasteless and odorless. But due to the presence of organic matter, due to industrial waste disposal, okay, it gives a different taste and odor to that water. Okay, and also sometimes due to percolation of water through the soil rocks, that also having a different odors. Okay, because of what? Due to dissolve of some chemicals into that water. So that also leads taste and odor to that water. Okay, so next one is temperature. Basically we prefer cool water for the drinking purpose, but as the temperature of that water going to be increases, that leads the growth of the bacteria. Okay, and it makes unsafe for the drinking purpose. So that is the temperature. Okay, so next one is turbidity. Okay, so in previous lecture we discussed about the temperature, and now we will start from the turbidity. Okay, so turbidity, it is nothing but the presence of the solid. Okay, so it is nothing but the suspended solid, it is nothing but the dissolved solid. Okay, so mostly it is due to the presence of the suspended solid. Okay, so collect you can collect any one sample. In case of rainy season, you can say a river or any, okay, ocean. So you get this red color sample. Okay, so that red color sample indicates the turbidity. That means what? Due to presence of suspended solid, due to presence of solid, either may be biotic, either may be non-biotic, or whatever the organic matter may be. Okay, so this type of solid which makes that water turbid. Okay, so it may be mud, it may be clay, it may be algae, or it may be microorganism. Okay, so that makes the water turbid, and that is nothing but the turbidity of water. Okay, so how to measure the turbidity of water? So for that we use the nephelometer. So nephelometer, it is a equipment or instrument which is used to measure the turbidity of water. Okay, so what is the principle of nephelometer? The scattering of light. Okay, so scattering of light, it is the principle of nephelometer, and on that basis, that nephelometer measure the turbidity of that water. Okay, so how it acts? So that nephelometer which pass the source of light. So there is one bulb, and when we want to on that nephelometer, it emits light, and that light pass through that sample. Suppose if there are presence of solid into that water sample, then that light gets scattered, and maximum the light scattering, that indicate the maximum of the presence of the solid. Okay, or maximum the turbidity. As light easily pass through that sample, so that indicates what? Your water is clear water. Okay, so absence of or less suspended solid present into that water. But if the light is scattered into different direction, that indicates that the maximum the solid suspended solid, and that indicates the maximum turbidity. Okay, so जर लाईट इझिली पास झाली तर तुमची लाईट स्कॅटर्ड होणार नाही, आणि त्या केसमध्ये तुम्हाला तुमची टर्बिडिटी आहे ती कमी दिसेल, मे बी 0 असेल और मे बी 1 असेल. ओके, बट सपोज जर लाईट जास्त स्कॅटर्ड झाली, लाईट स्कॅटरिंग का होणार आहे? ड्यू टू प्रेझेन्स ऑफ सॉलिड. त्याच्यामध्ये क्ले असेल, अल्गी असेल, बॅक्टेरिया असतील, मड असेल, सो दॅट लाईट आहे ती तुमची त्या पाण्यातून इझिली किंवा त्या वॉटर सॅम्पलमधून इझिली पास होणार नाही आहे. ती लाईट काय होणार आहे? हे जे सस्पेंडेड मॅटर आहे त्याच्यावर इन्सिडेंट होऊन त्या हे होणार आहे, स्कॅटर्ड होणार आहे. ओके, different direction मध्ये, and that is what the phenomenon scattering of light, and that is nothing but the principle of nephelometer. Okay, so on that basis we are going to measure the turbidity of that water sample. Okay, so NTU, it is a unit of measurement of turbidity, that is called as nephelometric turbidity unit. In that unit you can measure the turbidity of water. Okay, basically the turbidity vary from 1 to 5. That means you can accept that water for the domestic purpose when the turbidity vary from 1 to 5. Okay, 1 NTU, 2 NTU, 3 NTU, 4 NTU, 5 NTU. Okay, up to 5 NTU you can accept that water for the drinking and domestic purpose. Okay, so that is what the turbidity. So this turbidity is measured in NTU, that is a different unit of measurement, okay, in characteristics of water. Okay, so I hope you understand about the turbidity. Come to the next, chemical characteristics is important. Okay, so chemical characteristics, that various chemical characteristics, it may be pH, it may be alkalinity, it may be hardness, it may be chloride, or it may be the total solid. Okay, so first we discuss about the pH. So what do you mean by pH? pH, it is nothing but the presence of concentration of hydrogen ion into that water sample. That indicates the pH. Okay, so that P and H both are the different terms. So P, that indicates the potential difference between electrode, and H, that indicates the hydrogen ion concentration. Okay, so that means what that pH measure? pH measure the electric potential difference between that two electrode with hydrogen ion of concentration. Okay, and that hydrogen ion of concentration, it is nothing but the pH of that your water. Okay, so what is the principle of that pH meter? So the principle of pH meter, this pH meter, which consists of two electrodes, one is the inner electrode and one is the outer electrode. So outer electrode, it is a sensing electrode, and inner electrode, it is a reference electrode. Okay, so when these electrodes come in contact with a solution or sample, so then what happens? It generates the electric potential between the inner solution and outer solution, this pH electrode which contains the solution. Okay, and this inner solution and outer solution which creates the potential difference, and that potential difference measure the pH of that sample. Okay, so pH you can measure by the using pH meter. Okay, so one thing is that pH is unitless. Why pH is unitless? Because the pH is nothing but a number. Okay, we measure the pH from 1 to 14. So all you know, the pH 1 to 7, it is, you can say, acidic. 7 to 14, you can say it is alkaline. Okay, basic. And exactly 7, you can say the neutral. Okay, so when pH, it is nothing but what? It is just a number, so it is what? Unitless. Okay, so drinking water specification, if you consider, so for that drinking water we required the pH basically 7 to 7.5. According to IS, that unit may be 6.5 to 8.5, but basically we accept 7 to 7.5. Okay, so that about the pH. So pH, it is nothing but the presence of hydrogen ion concentration. Okay, you can measure pH by using pH meter. That pH meter, which consists two electrodes, okay, reference cell and a half cell, and which generate the electric potential between two electrodes, and that measure the pH. Okay, so this pH vary from 0 to 14, that is 7 is exactly neutral, 1 to 7 you can say it is acidic, and 7 to 14, that is highly basic or alkaline. An acceptable limit 6.5 to 8.5, and mostly we prefer 7 to 7.5. Okay, okay, come to the next point, alkalinity. So what do you mean by alkalinity? So alkalinity, it is, again, you can say when the pH is more than 7 to 14, that indicates that water is basic, that is what, nothing but alkaline. Okay, so that characteristics of water, that is called as alkalinity, or you can say that is what, alkaline water. Okay, next one is the alkalinity. If you consider the range of alkalinity for the drinking water, it is vary from 200 to 600. Okay, so that means you can accept water up to 0 to 200 mg per liter of alkalinity. Okay, for having the water sample having alkalinity up to 0 to 200, you can accept that water for the drinking and domestic purpose. Okay, come to the next point, hardness. So hardness, it is nothing but the presence of the salt. As the name indicate hardness, that we can say that water is hard. When we say the water is hard, when it contains salts of calcium and magnesium. Okay, so all you know, the basically there are two types of hardness. One is a temporary hardness and one is a permanent hardness. Okay, so what is my temporary hardness? Temporary hardness, it is nothing but due to the presence of, okay, bicarbonates and carbonates. And the permanent hardness, it is nothing but due to what? Presence of sulfate and chloride of calcium and magnesium. Okay, so these are the basically two types of hardness. One is a temporary hardness and one is a permanent hardness. The temporary hardness, it is due to the presence of bicarbonates. Okay, and what is the permanent hardness? It is due to presence of sulfate and chloride of calcium and magnesium. Okay, so temporary hardness you can easily remove by boiling of water. Okay, when we're going to boil the water, that hardness going to be removed. That means what after boiling, or that hardness, or that whatever that salt that going to be settled down at the bottom of your sample, okay, or water you can say, so that you can remove that temporary hardness easily. But in case of permanent hardness, it is not possible to remove easily that permanent hardness, so we require some special treatment, and that special precaution that is called as ion exchange method. Okay, so you can use ion exchange method for that removal of the permanent hardness. Okay, or also you can say zeolite method. So that zeolite method also you can use for the removal of the permanent hardness. Okay, why hardness? Due to presence of the carbonates, bicarbonates, chloride and sulfate. Okay, next, hardness, the limit of the hardness. So hardness you can accept up to 0 to 200 mg per liter. Okay, so when the water is more than 200 mg per liter up to 300, you can say it is hard water. Okay, and basically the hard water is not acceptable for that drinking purpose. Okay, so basically we prefer the soft water for the drinking purpose. Okay, so when the hardness is less, 0 to 50, you can say it is a soft water. When the hardness is more than 300, you can say it is a hard water. Okay, सो हे जे दोन्ही आहेत हार्ड आणि सॉफ्ट वॉटर हे तुम्ही कसे आयडेंटिफाय करू शकता. सपोज इफ यू आर गोइंग टू वॉश अ क्लोथ, जर तुम्ही कपडे धुताय तर त्या केसमध्ये साबण तुम्हाला जास्त लागतोय. ओके, तुम्हाला फेस कमी तयार होतोय, साबण जास्त लागतोय याचा अर्थ काय होतोय, दॅट इंडिकेट्स हार्ड वॉटर. ओके, म्हणजे याच्या अपोजिट जर तुम्ही कमी साबण यूज करताय आणि तुमचा फोम जास्त होतोय, लेदर जास्त होतोय, सो दॅट इंडिकेट्स सॉफ्ट वॉटर. ओके, so that is the two condition, you can say hard water and soft water, you can easily identify in your day-to-day life. Okay, the next one is the chloride. So chloride and total solid that we discuss in the next topic.